SOHCAHTOA, and we have V naught. That's a V, not an NO. And this is a V naught X and a V naught Y. We covered the heck out of this, so I'm just going to burn right through this. Alright, so you did SOHCAHTOA. I'm not even going to write that down. SOHCAHTOA, and that was sine of theta equals opposite of hypotenuse, cosine of theta equals adjacent of hypotenuse, tangent of theta equals opposite over adjacent. And then we did this. If this were theta and that were that, then this would be V naught cosine theta, and this would be V naught sine theta. Next part, I have you solve a problem, and this is kind of separate from the thing. And it's a drop a ball off of a cliff, just dropping it, not throwing it up, down, whatever, left, right. It's just dropping it straight down. The cliff is of height h, and we're assuming that gravity is pulling this thing down. And it splashes into the water. And let's see. What I wanted to know is how long. Still want you to take notes on this stuff. Alright, so the 4 equations that you have you probably have memorized by now. Yeah? Mm-hmm. Yeah, okay, alright, cool. This V final equals, in fact, instead of writing the little f, is there easier if I just write V? Mm-hmm. Alright. If it's V initial, then I'll write the little 0. Okay, V final equals V initial plus AT. Delta X is equal to 1/2 V naught plus V times T. We also have delta X equals V naught T plus 1/2 AT squared. And then you also have V squared equals V naught squared plus 2A delta X. We cool with that? Mm-hmm. Now, here's what you told me. You told me that the third one's the right one to choose because we don't really care or know anything about V final. So therefore, we're just like, all right, number 3 is a good one to choose. So we used that one, and we said, okay, delta X equals V naught T plus 1/2 AT squared. And we evaluated it, but like we did just now, we forgot to make a coordinate system. So we decided to call your coordinate system positive in the up direction, positive in the right direction. Now, the right and left direction don't make any difference whatsoever because this thing is not moving in the right and left direction. But in the up and down direction, that makes a difference. And you decided, not wrongly, just maybe you like harder problems to call up positive, and that's fine. Okay, fine. Before you do anything, you plugged in V naught is equal to 0, so we can just kill that thing altogether. Now, I'll give you a hint. In the later problems, V naught won't be 0. V naught will be whatever V naught is. Now, your delta X is actually H, because that's how far it traveled. But in this particular case, it was negative H. That's how far it traveled, because you called up positive, so therefore down is negative. It also went to negative 1/2 GT squared. Actually, you put 1/2 negative G, but I mean, if you multiply it all out, it's going to be negative 1/2. Those negatives cancel. I'm going to do that right off the bat, make it easy for us. Multiply both sides by 2. 2H equals GT squared, and 2H over G is equal to T squared, and T is equal to the square root of 2H over G. Are we cool? Mm-hmm. Mathematically, technically, you're supposed to have a plus or minus here. Have you ever heard of that? A plus or minus? Mm-hmm. Did you know that?
For the square roots, yeah.
Yeah, it makes sense, because it's almost like if I told you T squared was equal to 4, then T is equal to the square root of 4, which is 2, but T can also equal negative 2. Mm-hmm. Negative 2 times negative 2 is still 4. So that's why they have a plus or minus. But physically, we disregard the negative part of the T. Why do you think we do that?
We disregard the negative part of the T?
Yeah. Yeah.
Because you can have negative time.
Because there's no such thing as negative time. We're not going back to the future here. It's positive time is all we're considering here. We cool with that? Mm-hmm. Alright, part 2. I ask you to throw an arrow off a cliff like that, horizontally. Shoot it off a cliff. Bing! Like Hawkeye. It does have a V naught, but this particular V naught, and we had a discussion about this, but this particular V naught is not only, I mean, it's not in the y direction. It is only in the horizontal direction by design of the problem. Are we cool? It still falls a height h. My question is, how far does it go? Range r. And we're assuming gravity. So how far does it go? Cool. And I think that's where we're at right now. So why don't we put this on pause?
Okay. So for the horizontal, we solved range, which is r equals v naught times the square root of 2 times height divided by gravity. And then
Yeah, you got that's the answer. How did you get there?
How did I get there? I had to. Can I write on here?
Yeah, go for it.
So this, we solved this, and it was basically the third equation, but substitute h with r, and just solve it. I put cross out the second part because horizontal has no acceleration set equals 0.
Very good.
And then so range equals velocity, or v naught times time.
Very good.
And then we just solve that, and then we solve for time, and that's 2h divided by gravity, square root of that. And so I just put it right over here.
Yep.
So I got that.
That's it. So you looked in two different directions, and you have to analyze each direction. There was a special part of each. On one of them, the horizontal part, there was no acceleration. On the vertical side, there was no actual velocity. So you need to evaluate, make sure you're careful with that. Cool? Moving on. Sweet. Right. Where's my pen? There's. Well, here's the next one I want you to solve. Same scenario as the very first one. But the question is, how long will it take? No, not the exact same scenario, because this time I'm throwing it up with the initial velocity. The very first one, I actually solved it so that it had no initial velocity. In this one, I actually have a positive, or depends on which way you want to call it positive, but I have an up initial velocity. Does that make sense?
Okay, so to solve this problem right here, we went back to Algebra 2, and we did sort of like the quadratic formula, and we just replaced it. A is really g, while B is
A is actually 1/2 t.
A is 1/2 t, excuse me. B is v.
Negative v naught.
Negative v naught.
Yeah. You got v, I don't know why you got v, it's negative v naught.
And then C is h.
Negative h.
Negative. And so we went back and we put it on here.
That's quadratic formula?
Yes.
Okay.
And
Just plug it in. How'd you get there? Which equation is this?
it's the third equation.
The third equation. Now, why is h positive?
Because on the graph we used positive
Which way?
going down.
Alright, then why is v naught negative?
Because it was going up from that's the negative.
And that's negative direction if you're saying down to positive. That makes sense.
Yeah.
Why is g positive?
Same reason h is, because it's going down.
Why isn't v naught 0? Let's just do it initially. Look up at the top. You cancel it out.
Because v naught, we decided it's 2.
Right. In the previous columns, v naught was 0. In the vertical direction. Now in this problem, you don't have to look in the horizontal direction or the vertical direction. You just have just one direction to worry about.
Yes.
Okay?
Yes.
Alright. Now here's the thing. The final exam is basically this plan. Shoot off with the Bruno and theta. Cool? This is how I want you to solve it. I don't want you to give me numbers. I don't really care about the numbers. Just do the shoot off with any V naught.
in any case, and this address if you want, you're going to have to take a look at how long it takes for it to come down. Just like what we did here. How long does it take? And we figured out over here, right?
Okay.
And you also figure out how far does it go in that time. But just to give you a hint,
The
the final exam is basically a combination of all those three problems. You can mess with those three problems, but you can clear this one for that first part.
Mm-hmm.
Are we cool with that?
Very cool.
Alright.